It's vlog number 3, and today we're gonna find out how Kanaria Tech is dealing with data challenge. Let's get started. In the last video, you explained foundation models and introduced KRM and promised to share how Kanaria handles that data challenge. Can you first explain what you mean by the data challenge?
So for training such foundation models, we need very massive and then very structured data. And for GPT, this data was the text from the web. So the GPT was trained on to predict the next word in the text, and then it internalized the structure of the language. So for KRM, we also need similar type of data, which means structured and relevant for navigation. So when we say data challenge is the availability of such data for training such foundation models.
So the challenge is not having enough structured data we can train robotic AI models with. For social navigation specifically, what kind of data do we need that we don't have?
To navigate socially, KRM has to um, understand, learn how the people are actually navigating, how people are walking, which includes observing the human behaviors and understanding the social cues, and also learn how to giving way and or waiting in the queues. So that means we need a footage of such data in which the agent or the person who is behind the camera, it can be a robot or a human, is navigating in a socially aware manner. For this purpose, there are two obvious ways of gathering data. So first option out of these two options is collecting data from the real robots. That means we can deploy the robot in real world, and then we can teleoperate them so that they can move, they can navigate in a socially aware manner. So it looks like very structured and clean data. However, it has two main drawbacks. The first one is it doesn't give us high enough variance. That means we need this kind of data gathering from different locations, different cities, and different conditions. But for that, you have to deploy like hundreds or thousands of robots in different locations, which is not feasible. The second one is scalability issue. That means if we teleoperate robot for 1 hour, we will end up with 1 hour of data. If it is 2 hours, only 2 hours of data. So it's not scaling very well. That means we don't have any opportunity or chance to gather larger data in a limited time.
Real robot data is not scalable. What was the other option?
So second option is to generate synthetic data from the simulation. So this option actually addresses the drawbacks of the first option, which was not scalable and which was not high variance. So we can address these two drawbacks in a second option, because in simulation we can build different environments and then we can generate data which is much more scalable than the real data gathering. However, in this simulation, there's another problem, which is it's not representative enough of the real world. Because again, for social navigation itself, we need the humans with behaviors, human with intentions to walk and to navigate, but we cannot represent them all very cleanly in the simulation. So that means the second option is also not feasible because of this reason.
So both options fail is a general challenge for every physical AI companies?
Yes, indeed. For almost any physical AI companies, data is the biggest challenge and the biggest problem. And it was same for Kanaria Tech as well. And because of the reasons I mentioned just now, we stopped choosing between the first option and the second option, and then we started to look for the another way of unlocking this challenge.
Oh, so there is another option. How does Kanaria get around it?
In Kanaria Tech, we changed the question we ask while gathering the data. So usually, models are asking for the robots what action to take in a given in a given scenario. But we changed the question from this to how the camera has to move in a given scenario. So the change of question also defined what kind of data we should gather. And because of this reframing of the question, so we end up being able to use any like egocentric video. That means any video in which the camera is navigating among the people. So it can be captured by a robot, or it can be captured by a human, or vehicle, or bicycle, whatever. So the only interest was how the camera is moving in this kind of crowded places. This way, the internet becomes our potential training data.
Now you have access to massive data on the internet. And how do you make it ready for training?
Yeah, for accessing data, the idea looks quite simple, but the execution is not that simple. And we build internal tools to make these videos and to be trainable for AI model. So that means it has to be structured data. So we get the unstructured videos, and then we have to make certain type of pre-processings. So we can share the idea. We share the idea, but the execution is like confidential IP in Kanaria Tech. If you want to learn more, please reach out to us.
Thank you, Alishar, for letting us sneak peek into KRM's development and what's coming next.
Thank you for the session, and I'm very much looking forward for the next videos. Starting from the next videos, I would like to share about KRM's distinctive features. See you.